In this video, we'll be talking about more about the similarity between two cylinders and the experimentation which has been done on the Minutia Cylinder Code paper. So, in the last two videos, we have talked about the local structure of the Minutia Cylinder Code and the values of cell. Now, in this case, we have three cylinders CA, CB, and CE, which you can see on this slide. And for each cylinder we have cell values which has been shown as a small cm. So to calculate the similarity we have linearized this value by this expression. Now where small CB is a cell value or the cell value of a cylinder A and cylinder B. Now, if CA and CB are matchable means they are valid, then we will given a value C of T, else 0. The same case it goes with CBA. If they are matchable, then we'll give you value CBT. Now we'll calculate the similarity between two cylinders as gamma of A comma B is equal to 1 minus mod of CAB minus CBA upon mod of CAB plus CBA. Now it is interesting that CBA are those values it is a cell value, so it probably will be in the form of vector. So now in this case we got a value as gamma AB is equal to 0.75 and gamma S is equal to 0.38. Now moving to the next slide. In this slide we have implemented bit-based implementation of the Minutia cylinder code for matching to cylinder. So in this case, as you have seen, then when we calculate the cell values of particular IGK cell, so we were getting the value between 0 to 1 including the real point. But in this case, when the value will be in the form of 1 and 0. In this case, sigmoid function will be given a value only 0 and 1. So now, so if we are getting a value 0 and 1, then our CMIJK will be either 1 or 0. Now if it is 1, then we will given a 1. If it is valid, we have talked about, so every cell is not valid, there are some condition, according to that they are valid. If it is valid, then we will given a 1, else 0. Now we are calculating the value CAB cap of cap CA and operator CB cap from the same formula is just has been derived in the different form just to calculate is bitwise. So here we are computing the value gamma bitwise of A comma B, which are the cylinder 1 minus CAB or CBA, which is mod, and mod of CAB plus CBA if both cylinders are matchable. We have also talked about the if how can we say that two cylinders we are going to compare the similarity are always will be comparable. So now in this case AB is 0.6. So in the last we have seen the gamma AB is 0.7, but in this case gamma AB bit is 0.6. It's because we are not getting the value between 0 to 1, we are getting the value only 0 or 1. So it's obvious to get the value, it's a similarity less than or less than the what we have got in previously. So moving to the next slide. Now we are going to calculate the all the values on the globally. So suppose in the first fingerprint we have got in a cylinder, in the second we got NB. So we'll have a matrix of 0, 1 Na cross NB. Now we need to calculate gamma of AR comma BC over all the element. Now the simplest one algorithm to calculate is just sort all the pairs and select the top NP pairs. Now the NP pairs we need to define. and it depends on totally how you are going to calculate your similarity. Now, local similarity assignment, LSA. In LSA, we are using a Hungarian algorithm to find out the top NP pairs to calculate global score. Now, the third technique is LSS with relaxation, which local similarity is sought with relaxation, which we'll talk about in the next page. But there is also another technique which LSA with relaxation, which is the derivative of LSS. The difference is that it in the preliminary steps it uses LSA technique to select NR pairs, and then uses the LSSR method. So it's just a derivative of LSSR and LSA. Now moving to the next point, we will talk about the LSSR method. Now in LSSR method, we generally do what we do. We just we just strengthen those pair of minutia which are compatible own in their own corresponding minutia minutia of fingerprint. So particularly, suppose we have given a pair of A comma B, if the global relationship among A and the some other minutia in capital A are compatible with the global relation of small b and the corresponding minutia in capital B, then we'll strengthen the pair A comma B, else we'll going to penalize this pair. So as you can see, initially the value was lambda t I. After I iteration, will be giving a weighing factor which is rho t comma k, which has been typically has been calculated in this paper, which I am not going to describe all this in detail. So this is what we get, and as I have said that it selects NR pairs. Now coming to the experimental evaluation. So there are four diagrams in this slide. The top left diagram is equal error rate. It means the less ERR, the better the algorithm is. So which you can say the 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 small the 3% all the diagram which you can see, this is a height of 3% is better than the height of 11 or 12%. Now in the right section, these are the algorithm which are mentioned here: MCC 16, MCC 16B, MCC 8B, Jiang, Radha, Feng. What are these? These are the Minutia Cylinder Code. 16 means the value of NS is equal to 16. The value of NS is equal to 16, but it is bitwise. NS is equal to 8 and it is bitwise. Jiang is the algorithm based on the paper published by Jiang and the paper published by Radha and a paper published by Feng. Now which you can see that the top three, which is MCC, the derivative of each other, is shown from left to right in this form. So which we see the ERR value are lower than as compared to other three, and if we see again, then as we use the technique LSS, it is higher for 3 only, but I'm talking about the only MCC, it is higher. For LSA it is lower, then gets lower, then it gets lower. So as we can see that MCC are better in equal error rate. Now coming to the FMR, which is false match rate among 1000. Now this is the same thing, MCC top 3 and the other algorithm published by Jiang, Radha and Feng individually separately. Now in that case, we see that FMR rate is declining and declining as we change the technique LSS, LSA, LSSR, LSAR, and for 3 MCC are better than the rest of Jiang, Radha and Feng algorithm. Now coming to the right top part, in which we have matching time. So in this case, TCS is the creating local structure of minutia, and this is the calculating the calculating similarity score for a local structure, and this is the calculating the local structure, calculating the global score of my Minutia. Now, for MCC 16, MCC 16B, MCC 8, which we can see the time is the, the time are higher than the Jiang Ratha Feng. Okay, and the interesting part is that if you use for for any algorithm, LSRs LS, LSS technique takes less time as compared to LSSR. Now, the point here is the catch here is if MCC Minutia Cylinder Code is basically made for those devices which has less computing mm, computing capacity. So it is not going to that affect that much because it doesn't take more than 1 second. And but to calculate Jiang, Ratha and Feng algorithm, we need to high competition, and accordingly the device which has a high capacity to compute. Now, again, the average memory size of the local structure. So if you see, generally MCC has higher memory size than Jiang, Ratha and Feng, but MCC 8B has comparable with the Jiang, Ratha M and Jiang, Ratha and Feng. But also it is noting down that we can compress MCC 16B or MCC 8B for 65% or to 95. It is because in the zip format, yeah, basically, yeah, of course, it is because the these two format MCC 16B and MCC 8B are in the bitwise format, so it can be compressed easily. So so after after completing this paper, we need to know about this paper is uh, basically about the implementing the fingerprint algorithm on a machine which has less computer less computing time, memory, and we can use as a portable fingerprint efficiently. Thank you.